All right. Hello, class. Now, who's going to the seniors versus faculty game to watch me dunk on some kids?
I just wanted to eat a cookie.
It's on the
That's Tuesday.
the 12th, Tuesday.
I just want to see you getting cooked.
No, I'm gonna be winning. I'm gonna be raining threes. I'm gonna extend the floor. I'm gonna post up. Get a few dunks in.
Yeah.
Get a few blocks
I just
in.
want to go because I don't want to go somewhere.
Okay, you can't just show up. You gotta have a $2 ticket.
Yeah, I know.
Okay.
$2. Not. Okay.
Depends.
What you mean depends, bro?
I mean, if you pay your $2 ticket,
Oh,
then
yeah.
I'm sure you're good. But if you try to just sneak around, then yes,
So I'm just gonna go see.
that's the
so
team
either-
thing. How? They're fundraising for something.
I
Look,
didn't see
if
it.
you're gonna be if I'm gonna entertain, it's gotta be money. No, I'm gonna be. I'll have my sneakers on. Be warming up. Got my headband on. Got my tube socks all the way to the knee. Classic. Like the '80s shorts. You know what I'm saying? Yeah. What band's here? Yeah, yeah. On the teacher side, Mr. Lee. Whatever. I'm not sure exactly where, but Mr. Cavazos. He's that tall new math teacher. He's a baller.
Wait,
He's like the Wimby of Lee High School.
Oh.
Yeah, yeah. Miss Sutherland. Who else? I mean, we'll see. You know what? She's probably better than me, so I'm not gonna say anything. I'm just there. I'm saying I'm there. I'm there to make y'all laugh and entertain you. I'm not that good, but I'm still gonna get a three. I'm still gonna get a three from half court. Watch out. From the logo backwards. You know, you're gonna be crying. It's gonna be so good. You're gonna be like, this guy's better than Cooper Flag. It's crazy. All right, y'all ready? We are gonna win. I guarantee it. Otherwise, everyone gets a prize, some sort of prize. I don't know what yet. Maybe. All right. Well, let's do this. So y'all remember how to do this? Because if not, well, that's not good. Because there was like 2 or 3 assignments on this, right? 1, 2, 3, 4 assignments that I'm about to put in where you have to use the matrix calculator. All right, here we go. Let's make a new matrix. It's 2 by 2, right? 2 by 2, 2 by 2. All right. You hit enter. All right. And then you do another new matrix. Oh, really? I know better. You were looking up my highlight reel. All right. And then A, since it's multiplying, yeah, A times B, and I get -7.5, -38.20. It's too easy, Mr. G.
Hey, so can I go to the bathroom now?
No, because we're about to do notes, bro. Bro. Can't last like 1 minute without it. Free.
Hey, I already have those. Why? These are different.
All right. Come on, you got the notes. All right. Let's do it. Hey, you want to keep this short and sweet, right?
Yeah, I want to.
Unless you want to hear me talk. All right, here we go. I'm trying, but y'all got to listen. Here we go. All right. Y'all can, well, it's already written down, right? Okay. So, the determinant, y'all know what a determinant is? Okay. Every square matrix has a real number called the determinant. The determinant is denoted with determinant, DETA, or those vertical lines A. And the determinant of a 2 by 2 matrix is called a second order determinant. To find the determinant of a 2 times 2 matrix, use this rule. Now, This is how, if you want to do it by hand. So let me tell you, if you just multiply the top left by the top right, and then subtract the bottom left times the top right, that'll give you the number, okay? I can show you how to do it by hand, or there's a calculator. All right, let me just show you the calculator. Actually, I'll do one of these the old-fashioned way. You ready? So it tells us to do A times D. So watch this. -4 times -10, okay? -4, write this down. Wow. And then minus C times B, so it's the bottom left times the top right, 5 times 3. Now I can type this straight into the Desmos. I'll just do mental math. Negative times a negative is a positive. 4 times 10 is 40. Minus 5 times 3 is 15. What's 40 minus 15? 25. In theory, you can do that. Okay? You want to know the shortcut? Of course you do. Let's do this. All right, so, oh my goodness gracious, what's he doing? He's dropping the ball like Spurs. All right, here you go. So watch this. If you plug in your original matrix into the matrix calculator, okay, you hit enter. Do you see at the bottom? It says DET. That's the determinant. Okay, so if I click determinant, and then since I just put this in, it assigned it letter A. I hit enter. 25. You can do it by hand. You can do it with the calculator. I don't care. Then however you want. I just got to show you how to do it. Okay. So what about number 2? Can we do the determinant on number 2? Let's go straight up calculator on number 2. Ready? All right. So 2 by 2 matrix, -6, -3, 11, -2. Enter determinant of A gives me 45. It's too easy if you know how to use the calculator, right? Now, so far it's been a 2 by 2. Can we do it for a 3 by 3? What do y'all think? Well, let's find out, because actually, I don't even know. Minnesota's going to win by 10 tonight. No, they're going to win by 10.
Do you really think Anthony Everton can't?
Deet A. Hey, it worked. Yeah. Determinant of A gives me 75. All right. So do you know how to do it? Go to Desmos. You put in the matrix, and then you do determinant of A, and it'll give you the answer. Okay. That's the rules. Cool?
That's it.
That's half of what you learned today. The other half is the inverse. And guess what? There's a shortcut on the calculator for that too, but I'm going to show you how to do it, okay? Okay, so the identity matrix is with an I. Identity is like 1. You know how you multiply something by 1 and it stays the same? That's because it's an identity, okay? It stays the same identity. So if A is a n by n matrix, a perfect square, I is an n by n identity matrix, then they are basically commutative and they result in the same output. So look at these identity matrices, okay? What do you notice about the 1s and the 0s? See how the 1s are kind of like in a diagonal line like this? That's what an identity matrix looks like. Okay, so flip it over. This is already written for you on there, but the product of both of them is the identity matrix. So a matrix and an inverse matrix, when you multiply them, will give you an identity with the 1s going in a diagonal, okay? All that to say, let's determine, okay? So to determine if it's an inverse, you have to multiply these two, okay? So you're going to do A times B. Now I'm going to do this mental math, okay? Top left times the top left. Okay? -1 times 5 is -5. 2 times 2 is 4. Okay? 3 times 3 is 9. -5 times 1 is -5. Okay? Are these inverses? I don't think so, but let's find out. Too bad. Oh well, let's try this. All right, we got new matrix, -1, 2, 3, -5. New matrix, 5, 2, 3, 1. A times B. All right. So for this one, I do not suggest doing it by hand like this because there's some more rules to the multiplying that we hadn't covered really. But we end up getting 1001. Is 1001 an identity matrix? So you'll have to look on the bottom of the previous page, but does it look like this right here? The answer is yes or yas. Okay, so you're multiplying A times B in the matrix calculator, and then you're going to see if you get an identity matrix. Let's try it again, okay? So this one's -3, -2, -4, 8. Row. Okay, another new matrix, -1/4 row. -1/16, -1/8, 3/32. Okay, A times B. That type is right. -3, -2, -4. My bad. Yes, it does work. 1001. C times D equals 1001. If it looks like this, that's an identity matrix. The answer is yes, sir. Okay. Okay, last thing down here. Can you find an inverse? Okay. Let me show you. Wait, before you put your head down. Wait. Wake up. All right. So for the
sabotage.
for the rest of y'all, look. How do you find an inverse? You do a new matrix, type it in, enter, and see this right here? See that? See that? A -1? Okay. You gotta type the A, put the little -1, and it's gonna give it to you. It's gonna give it to you. It's gonna give it to you. And then you just gotta press this little fraction button right here, and it'll make it look nice for you. It's 1/2, 1/6, 1 2/3. Whoa! What was it? Oh, dang.
Hey, so can I go to bed now?
No, 1/2, 1/2, 1/6, 1 2/3. All right, I want you to try 7, 8, 9. Here we go.